So 4.2 is implicit differentiation. Basically what that means, the x's and y's are just all mixed up. So think about when we take the equation y equals x. When you take the derivative of this equation, what's the derivative of y? When we take the derivative of y, it turns into dy dx. When you take the derivative, think of it this way. The derivative of x with respect to x is just what? 1, right? When these are different, we just keep the dy dx, and we know the derivative of x is just 1. So when we're taking the whole thing in terms of x like this, if these are not matching, you just leave it alone. So technically, we've been doing implicit all along. All right, so let's consider this. When we take the derivative of this whole thing, first take the derivative of y squared, which is 2y, use the power, but then we also have to kind of think of y as the inside, kind of like the chain rule. Every time you do the derivative of a y, you need to chain on dy dx. And the derivative of x is just 1. So you take the derivative all the way across, and then to figure out what dy dx is, notice we just have to get dy dx by itself. I just divide both sides by 2y, and I get dy dx by itself, and we're done. So we're just doing the derivative of the entire equation. We just don't have y by itself any longer. Let's consider this one. Take the derivative of each piece, just go straight across. The derivative of x squared is 2x. The derivative of y squared is 2y. And because we're taking the derivative of y, I need to chain on dy dx equals the derivative of a constant is 0. I have to get dy dx by itself, so I'm going to subtract 2x. Divide both sides by 2y to get dy dx by itself. I can cancel out the 2's. So this is my derivative function if I want to find the slope of the circle at this point. I just plug 3 in for x, negative 4 in for y. So the opposite of x over y simplifies to positive 3/4. Now let's just look at this quick. Let's see if I can be a little bit. All right, this a little bit better. Oh. All right. So if x squared plus y squared equals 25, what that means is my radius is 5. All right, let's see if we can draw a circle. That's not too bad. Okay, so this is saying is at the point 3, -4, right here, if we were to draw a tangent line, I don't know how close I am. The slope of this line is 1, 2, 3, 1, 2, 3. So that should be a little bit more tilted. That's not too bad. All right, so if we graph a perfect circle, that's about as perfect as I can get. Draw the tangent line at this point, the slope of this line, up 3/4. Okay? All right, let's go to example 3. So show that the derivative is defined at every point. So we just start with the equation. Oops. Now, every time you see a y, you're going to need to chain on dy dx. The derivative of 2y is 2 times the derivative of y is dy dx equals the derivative of 2x is, or x squared is 2x. The derivative of sine is cosine. Chain on, the derivative of y is dy dx. Now, this is the first problem. We have 2 dy dx's in the same equation. So our goal is move all the terms that contain dy dx on the same side. So I need to move this to the left side, so I'm going to subtract it to move it over to the other side. So our goal is anything that has dy dx needs to be on one side. Everything that doesn't goes on the other side. Now, there is a GCF of dy dx. So I'm going to factor dy dx out of each piece. So if I factor it out of here, I'm left with 2 minus, factor it out of here, cosine y equals 2x. So I need to get dy dx by itself. So I'm going to divide both sides by this. And what the problem asks us, this is our function. This is our derivative function. It says show that the function is defined at every point. For something to be defined at every point, the bottom cannot equal 0. Why can this not equal 0? All right, so let's consider what would make it equal 0 is if I add cosine to the other side. Think about cosine of any value does not ever equal 2. Think of your cosine curve. It's always between 1 and -1. Cosine never equals 2. Therefore, 2 minus cosine y never equals 0, and it is defined. So just the basic steps: differentiate both sides, the entire equation, put all dy dx on one side, anything without dy dx on the other, factor it out, and get dy dx by itself. All right, tangent and normal, here we go again. So I'm going to take the derivative of the entire equation. Derivative of x squared is 2x. Be very careful. Two big things here. This minus and xy is a product. This is always going to get you, so be very careful. xy is a product, so I'm going to put my product rule inside parentheses, just leave the minus on the outside. So I take the first times the derivative of the second. So I'm just going to write dy dx because the derivative of y is dy dx plus the second times the derivative of the first, which is just 1, plus the derivative of y squared is 2y times dy dx, equals the derivative of a constant is 0. All right. Now I'm going to distribute my negative through, and I want everything that has a dy dx, so it's going to be this and this. I'm going to keep all this on one side. Now, I'm going to write this. I'm going to put my positive part first and then subtract off my x dy dx. I need to move over my y, and since it's negative, so I got to add it, I move over my 2x so it turns negative. So I kept everything with dy dx on the left. I moved everything that did not have a dy dx over and changed the sign. Factor out dy dx. Divide both sides to get dy dx by itself. All right. So if I want to find the slope of my tangent line, now I'm just going to plug in my point, -1 for x, 2 for y. All right, so I get 2 plus 2 is 4, 2 plus 4 plus 1 is 5. So I want both my tangent and normal. My point is -1, 2. So my tangent line is y minus my y value equals my slope times x minus my x. My normal, everything is the same except my normal is my perpendicular slope. So using the same point, use the opposite reciprocal of the slope. Everything else stays the same. Final answer. All right. Second derivatives get a little bit yucky, so just kind of be careful. All right. So first we take the derivative, 2x to the third, that'll be 6x squared minus 6y. Every time we do y, take the derivative of y with respect to x equals 0. I'm going to move this to the other side to make it positive. Divide by 6y. So my dy dx, the 6's cancel. I get x squared over y. All right, that's my first derivative. To find my second derivative, I need to do the derivative of the derivative. When we do the second derivative, notice the notation. D squared y over dx squared. So you put the second derivative with the d, and we're doing the second derivative of x here. This is a quotient rule. Square the bottom. Then we do the bottom times the derivative of the top minus the top times the derivative of the bottom. All right, so we have to be careful here. You cannot leave dy dx in the second derivative. You have to replace it with what it equals. So I'm just going to rewrite this as 2xy minus x squared times x squared over y all over y squared. Simplifying this is where it gets a little bit tricky. Okay. So when I multiply this, can you see this will just be x to the fourth over y? I'm just going to do that. All right. So I'm going to get a common denominator. So I'm going to multiply top and bottom by y. That just makes that y squared. So I get 2xy squared minus x to the fourth over y all over y squared over 1. Since I'm dividing by a fraction, I can multiply by the reciprocal. And I get the numerator 2xy squared minus x to the fourth all over y to the third. So it just gets ugly when you have a quotient rule with the second derivative because you have fractions within fractions. So get your common denominator, put it all together, multiply by the reciprocal. All right, the last one's not too bad. The one thing is going to be helpful. We know that the square root of x is x to the 1/2. It's really also helpful if you can make a transition from going the derivative of the square root of x is always just 1 over 2 square roots of x. We're going to try and transition. If you can't remember this, you can always take this step and finally get here. But I want to start forcing this transition that every time you do the square root of x, it's 1 over 2 square roots of x, or whatever underneath here. All right, but let's just do some integer or some rational stuff. The derivative of x to the 2/3, we still just drop the exponent down, subtract 1, 2/3 minus 1 is negative 1/3, which is the same thing as 2 over 3x to the 1/3. And technically, we could even write this as 2 over 3 cube roots of x. So just understanding how radicals have rational exponents. All right, and this last one, drop your exponent, subtract 1, negative 1/5 minus 1, negative 6/5. So that's our power. Be really careful. This is just the power portion. We still have to chain on the derivative of cosine. The derivative of cosine is negative sine. Now, we can simplify this a little. First of all, we have a negative times a negative. That just turns into a positive 1/5. This contains a negative exponent, so I can put that whole thing in the bottom. And this needs to be in parentheses. And once I move it to the bottom, it's turning to a positive 6/5. And I can just put the sign in the numerator. So this is a little bit more condensed. I just like it better that way. And that's all.